Hello, MPA. How are you guys doing today? Mr. Snyder here with the Swivl again. So, kind of follow me around the classroom a little bit as I move, face the other way today to try to make it a little bit easier. So today, we're going to talk about the rock cycle. And this is just the way the rocks move and change within the Earth. They move real fast? No. No, it's very slow. Millions and millions of years, if not more, to make rocks most of the time. So, this is just a little story about how each one progresses and can change. So remember, the key point here, it doesn't matter how the rock starts out. It's the process the rock goes through that determines whether it's a sedimentary, igneous, or metamorphic rock. Okay, first we have sedimentary rock. And the main way a lot of sedimentary rocks are formed starts with the weathering, erosion, deposition process we talked about back in Unit 1. So you have some kind of rock being weathered, broken down into small pieces. And then those small pieces are carried away by erosion and then dropped off someplace. That's deposition. So depending on how big the weathered pieces are determines what kind of rock's going to be made where. The bigger pieces of sediment don't get carried as far by water, wind, ice, gravity. So those are going to be closer to the original point, and those kind of rocks are going to have a coarse grain texture. Then as you go, the next larger particles, usually like sand and things like that, will get deposited off, and those have a medium texture. And then the very fine silt-like, almost mud-type particles get carried the furthest, and those are going to make fine textured sedimentary rocks. And there's three main kinds of sedimentary rocks. You have your, find them here, they're all mixed up down here. You have your clastic sedimentary rocks. So these just have hunks of sediment in them, cemented together. Again, these could be coarse, like this one right here. They could be medium grained, like sandstone. I drew a blank there. And then they could also be fine grained, like mudstone as well. Or they could be chemical sedimentary rocks. These are made from solutions. So solution, water has stuff is when water has stuff dissolved in it. And this is what's either left behind or precipitates out or forms a solid while it's in that solution. Then the last kind is your organic sedimentary rock, and these are made from living things. Okay, so you look real closely. If it focuses, I don't know if it is, I think it's focusing more on me. Let's see, move this closer. So focus on the sedimentary rock. I don't know. But trust me, there's pieces of shell in here from sea creatures and such. And so that would be organic sedimentary rock. Remember, organic means comes from living things. When you take organic chemistry someday, it'll mean something completely different. Next, you have igneous rock. And the process that makes igneous rock is you have rock being melted. And when that rock cools, it makes igneous rock. And there's two types of igneous rock. You have the intrusive igneous rock, which forms from cooling magma. And since it forms from magma, it's inside the Earth. The Earth acts like a natural insulator. And since it acts like a natural insulator, that magma cools very slowly, giving us coarse-grained igneous rock. As you can see here, in this rock, you see all kinds of pinks and whites and grays and black minerals. And it's a little bit clearer mineral as well in there. And since they have time, as it cools slowly, those similar minerals have a chance to find their like minerals and form these large grains or coarse grain minerals. That's intrusive igneous rocks. And then you have others that come out as lava and coal. And these form much different looking rocks. Here, this one has a bunch of holes in it because the air got stuck inside of it as it cooled. And then you have obsidian here as well, very glass-like, shiny. Again, no mineral crystal you can see, so fine grain right there. So igneous rocks, make an igneous rock by melting another rock and then allowing it to cool. So if it melts, it can turn igneous when it cools. Then last kind, metamorphic rock. And this is just how rocks, just changing one rock into a different form structurally, whether it's through high pressure, high temperature and pressure, That was a chair I ran into, by the way. And or by chemical means. So the longer time that you have these rocks exposed to temperature and pressure, the higher chance it has of having lines in it. As you can see here, you see different bands. You see dark bands, you see light bands in this rock, and this is what we call foliation. So you have foliated metamorphic rocks. This one too, you can see some layers in it. Not as pronounced as the other one. And it's a little bit shinier as well. Has some shinier minerals to it that glistens. That's another sign that usually it's a metamorphic rock when it shimmers like that in the sun. So those are foliated metamorphic rocks. Then you also have non-foliated, so there is no bands right here, like this piece of marble. Beautiful, beautiful piece of stone. But again, this is non-foliated because you don't have those bands forming from that intense pressure and heat. And that's my other example. And I believe this is our last slide. So remember here, MPA, that does not matter which type of rock you start with. It matters what process it goes through. That's going to determine what kind of rock it turns into. So sedimentary rocks, you have your weather and erosion deposition compressed together and cemented together, or it's from solution as well. For igneous rock, if it melts, it's going to, when it cools, it's going to form an igneous rock, whether it's intrusive or extrusive in the earth or out on the earth's surface. Is going to determine its mineral crystals. And then metamorphic rock, it's going to be foliated or non-foliated, and it's either under high pressure, high temperature that bakes, or high pressure and temperature, or some kind of chemical means that changes the structure of it as well. So have a nice evening there. Peace out, Mount Pleasant.